Can everyone see my screen okay?
Yeah, that's great.
Okay, perfect. So thanks so much. Good morning, everyone. I guess we can go ahead and start a little bit early.
Yeah,
or
sure. It's currently just not in full screen mode, so I don't know if...
Oh, okay. Here, let me... Okay.
Just play, yes.
Here we go. Yes.
Okay, perfect.
Yes.
Thank you so much, Shannon.
Thanks. Thank you. Good morning, everyone. My name is Shannon Houck. I'm a staff scientist at Q-Chem, and I want to thank the organizers of this workshop and also all of the TAs and all of the presenters for all of their hard work on putting together all the materials for this. We're really excited to show you guys what we have and hopefully have some fun exercises for you guys to work through, and also for you guys to learn a little bit more about what we've developed in Q-Chem. So we're really excited for this. So, and thank you to all the participants too for participating. I'm just going to give a quick introduction to IQmol, which is the, I guess I can explain. IQmol is sort of our free open source graphical user interface for Q-Chem, and also provides an interface to allow you to submit jobs and things like that, both to our Q-Chem server here, which has a 10-minute limit on the job time. And also if you have your own copy of Q-Chem on your cluster at your university or on your own local machine, you can also submit IQmol jobs or Q-Chem jobs via IQmol to your own server as well. So yes, sort of a little introduction to what the IQmol interface looks like once you open it up. You've sort of got your file management tools is the first thing. I don't know, I don't have my cursor here, but file management tools that allow you to create new molecules, open molecules that you've created previously, and save files. You also have the view/move mode as opposed to build mode. Build sort of provides you with a lot of different tools that you can use to build different molecules. You also have the select tools, which allow you to obviously select different atoms or bonds or whatever. And then you also have the visualize tools, as well as the help tools. And then also on the left, you're going to notice you have this model view dialog box, which allows you to select different molecules that you may have built. That's where you're going to find a lot of the output information once you get your output files back. And then if you're wondering how to undo stuff, that's the history box at the bottom, shows all of the steps that you've taken. And so in terms of building molecules, if you want to get started with that, you primarily, you primarily use the building molecules dialog for that. So, and you have all of these buttons over here. I've mostly provided this as a reference for y'all as you get started with it. And the easiest way to learn how to do something is to demonstrate it. So I'm going to go ahead and build Aspirin for you guys, just to show you how all of these buttons work in terms of creating an actual molecule. So if we go to here, I've already opened IQmol. And what I'm going to want to do is create a new molecule using this new molecule tab here. And then what I'm going to want to do is start from a fragment. So these are pre-optimized structures that are available for you to use as building blocks as you are building a molecule. So what I'm going to want to do is look under aromatics and find something that looks kind of similar, or something that looks like I can start from it to start building my aspirin molecule. So I'm going to start from this. And what I'm going to want to do also is add an oxygen here. And then you see this dialog box here also allows me to select different elements to place them individually. So I know that I need a carbon here and here. And then also I'm going to need an oxygen here with a double bond and another oxygen here. And you'll notice for the double bond here, I clicked on one atom and dragged to the second one. Now I'm going to use the viewing move tool to sort of rotate this a little bit. And as you can see, we've got this extra hydrogen over here that we kind of don't want. So we can use the select tool to select that hydrogen, and then this X here allows you to delete it. And then we're going to want another double bond between this carbon and this oxygen. And then we're missing a lot of hydrogens here, right? So one thing that is useful to do is this, under this build menu, you can also fill valencies with hydrogens. And you'll see that just added all of the hydrogens that we wanted. You'll also note that this is not necessarily the ideal structure to start with. There's a couple of things that are a little, out of place looking. So what we can do is we can minimize energy to get us a little bit closer to what the final structure is expected to be. You'll see this sort of flattened out a little bit and spaced things out a little bit more appropriately. So yeah, so this is there are maybe some tweaks that could be made here, but this is a reasonable starting structure that you could then go do a geometry optimization on or something like that. So going back to this. There we go. Oh, and in terms of measuring angles bonds, sorry, I forgot to demonstrate that one. If you want to measure the bond length, you can click with the select tool, and that in the bottom left-hand corner should give you the bond length, angles as well, and then torsion angles. So, all right, back to the presentation. Once you have built whatever molecule you want to run a calculation on, the next step obviously is running the calculation itself, which you can do from the calculation menu. So you use the calculation menu and then go into Q-Chem setup. That allows you to select all of the different parameters, like what functional you want to use, method, basis set. If you have any like specific control that you want to do on, the number of optimization cycles or something like that, that's all done under that bottom dialog. And then there's some advanced things that you can do with this as well. In terms of monitoring the jobs after you've submitted them, also under the calculation menu, you have the job monitor, which allows you to monitor job progress, see what's failed, see what's errored out, see what has been successful, and see what's still running. So, and this basically, it just goes into a little bit more detail about what that dialog box looks like. So like I said, the setup is sort of that top left-hand corner stuff. And then you can actually see the input file that's generated to Q-Chem on the right-hand side. You also have this little submit button there. You'll also note the server button, or not button, drop-down menu, which does allow you to select which server you're submitting to. So today we're all going to be submitting to the Q-Chem servers, which it's just a server we have in the office here. But if you have your own local server set up, you can actually hook IQmol up to that and submit to that instead, which a lot of people prefer to do if they're running longer jobs. So you also see this little reset button, which you use between jobs to clear your rem variables from previous jobs. So in terms of submitting jobs, I'm going to demonstrate that again as well. I'm just going to run a quick new molecule. And now I'm just going to run a quick frequency calculation on acetone, which should be under ketones. There we go. This guy here. And then calculation, Q-Chem setup. And then I'm going to want to run a B3LIP 631G calculation. So that's the appropriate method, the appropriate basis set, and then frequencies. And I actually forgot to clear this out. Normally the defaults are this for running a new job. So I'm going to set this up this way. And then you can see there's a lot of different things here that you can choose in terms of what you select. Also, if you want to, you can actually directly edit your input over here as well. So if I wanted to manually change the method to, I don't know, a Minnesota functional or something like that, I could do that here. Although it is also available over here, but yeah. So now that I've done that, I've got the Q-Chem server selected, and I can go ahead and submit this. And then we're going to go ahead and call this frequency job. Okay, and that's going to run. We'll go back to the presentation while that's running. So, oh, I should actually monitor it. I'll show you guys that too. Yeah, this is just what the job monitor looks like. So you can see I've run a fair number of test jobs in preparation for this workshop, but you can see the one we just submitted is running, and it should be done in probably about 20 seconds. So while we're waiting for that to finish, we'll talk about analyzing the output. There's a lot of different things you can do with IQmol. Our IQmol developer has put a lot of time and effort into, you know, making sure you can do a lot of different types of fun and exciting things with your Q-Chem output files. And it makes visualizing a lot of the output a lot easier. So you can view the raw output files themselves, obviously, but you can also visualize like molecular surfaces, canonical and Dyson orbitals, which you'll be doing later today in Anna's workshop. You can look at like the total density, Mulliken charges, stuff like that, and electrostatic potential stuff. You can also track geometry optimization steps if you're doing a geometry optimization, just to, you know, make sure that it looks like it's converging to something reasonable, or if it's not converging to something reasonable, you can tell it's kind of, you know, oscillating between two structures or something like that. You can also generate high resolution PAVRE files, which we're not really going to get into today, but if you're looking for high resolution graphics for a paper or a presentation or things like that, that's a really good way to get those. So you can also look at frequencies, spectrums, stuff like that. And yeah, there's also a lot of other resources available. There's a lot you can do with IQmol. So, and we're not getting into all of it today. But in terms of other additional resources that you can look into to learn more, obviously there's the website. There's a very extensive manual as well that you can look at that sort of goes into slightly more detail on how to do various things. It's very thorough. And then we also have a lot of webinars with both like beginner level stuff and more advanced stuff as well. So, well, before we get into the exercises, it's jumping, which means that it has finished the job. So we're copying this back, right? So we're creating a, well, I should create it in the right directory, actually. We'll create that, and then we will open this. If I tried to open one of the other directories, it would ask me if I wanted to overwrite that directory, which I don't. But you can see this has finished now. And then we can visualize the frequencies here. So you can see it's sort of wiggling, right? We can also look at surfaces. We'll stop that. And then we can look at the HOMO and LUMO of this. So if we want to calculate those, calculate, and we can visualize those. So you can see this is the HOMO and then the LUMO as well. If you want to visualize them on top of each other, you can also do that, but I don't necessarily recommend it because it's not really meaningful. What you can also do is plot the, you can double click on canonical orbitals to plot the total density as well if you want to. So calculate that. And then on top of the total density, what's really nice is you can actually plot like the electrostatic potential on top of this. So you can see that that oxygen is pulling a lot of the density as well. So that's nice. Yeah. So in terms of visualizing the frequencies, what you can actually do also is if you double click on frequencies, it actually gives you this really nice visualization of where all of the peaks are. And actually, if you pull this over here, make this a little smaller so y'all can see it. I double click on this and press play, it will actually show you the frequency that's associated with that peak. So, and then you can do that for this one as well. And this is what we would expect experimentally as well, for this to be the primary stretch that you see, or the one with the highest magnitude. So anyway, so that's pretty cool. And then there's a bunch of other stuff, like I said, that you can do with this as well. But I just figured I would show you guys that. And then now I'm going to hand you guys over to the exercises. I don't know if y'all were given the link to the Google Drive, but I'll go ahead and post it in the chat anyway, just for the sake of having that. But there's 3 labs. The first is going to focus on building the molecules. The second is going to focus on visualization and stuff like that. And then the third lab is going to teach you how to do some slightly more advanced stuff with the command line interface, or the job submission interface. And then also look at visualizing spectrums a little bit too. So I think there are a lot of questions in the chat as well. So okay. So okay, as someone is asking what the level of theory is for the generation of the coordinates. I do not know what level of theory at which those coordinates were generated. That's something that I would maybe need to ask our developer. But I can answer the second question, which is, sorry, I should read the question out loud. Where do the coordinates come from? Furthermore, is there a way to access these coordinates as text files? There is a way to access the coordinates as text files. They're actually, if you look under the directory that your IQmol is stored in, you can actually see under, I forget exactly what directory it is, but they are stored within the IQmol program under a specific directory. And in fact, if you want to add your own, you can actually add your own directory under the top level directory, and add your own fragments if you choose to do so. So yeah, I can provide more information on that. If you email support@qchem.com, I can give you a specific path to that. What does local server mean? So we have our server here, right? So we have a machine in our office that will run IQmol calculations, but we have a time limit, a time cap of 10 minutes on that. And so if you have your own server, like if you have your own machine in your own office, your own workstation, or for example, a supercomputing cluster at your own university that you would prefer to use, you can use that instead. And you can submit jobs via IQmol's interface to your own computing infrastructure rather than ours. And then there won't be a time limit associated with that, because you're using your own resources for that. So yeah, and it looks like someone was kind enough to answer that question for me in the chat as well. And okay. Can it be used for periodic DFT calculations? Not right now. That is something we're hoping to do in the future, but it has not happened yet. So these recordings are being, sorry. Someone is asking if you can find the recordings under the archive section. That will be a case, yes. Sorry, there's a lot of questions in the chat and I'm trying to answer all of them, but
yeah, I
that's
do
not
think
the most
that,
efficient way of doing it.
There is a lot. I think the rest of the Q-Chem team seems to be like really on it and answering the questions as you go. Okay, so there is a question about what's the difference between canonical and Dyson orbitals, which feels like it hasn't been answered yet. So you can answer that one, but everything else I think has actually been answered.
Okay, so canonical orbitals are solved. Those are basically the orbitals that you get by solving sort of the Hartree-Fock or the normal equations, or couple cluster equations, or you diagonalize the Fock matrix basically, and those give you the canonical orbitals. In terms of the Dyson orbitals, those I believe are those are solved by the those incorporate I think complex numbers as well, rather than just the non-complex component. So so there's the real component and the imaginary component, and Dyson orbitals, I believe, incorporate the imaginary component. Yeah. So yeah, that's, I don't know that that's necessarily a super thorough answer, but we'll be talking about the Dyson orbitals later in Anna's couple cluster talk. And so, yes, yeah, thanks.
And then there's a question which we did have the other day on one of our discussion panels as well, as to whether there's any support for academic researchers from least developed countries to install Q-Chem on their desktop. As MolPro and some of these other commercial packages do this for free for researchers from developing countries.
So in terms of installation, we have a free 2-month trial for people, and then anyone can run IQmol, or anyone can run calculations with IQmol through on our servers with the 10-minute time limit. We do not offer free Q-Chem licenses for researchers from developing countries. But again, the 2-month trial is totally free for folks to try, and that's fully functional. So you can do any sort of calculation you want with that. And then also, again, the IQmol server is totally usable. So yeah. Okay, thanks. So I guess I will, oh, okay. Someone's asking what gives Q-Chem an advantage compared to other softwares like TurboMol and Orca. We've got a lot of density functionals, so we've got like over 200 of them. And we also, so our wide range of density functionals is one advantage that we have. Our integral engines are fairly fast. And then also, I think one advantage that I think Q-Chem has is our developer community. So we have a very large, I guess, like Sharon mentioned, there's a large community of developers, like 300-400, something like that. And there are academic communities from all around the world that make active contributions to Q-Chem. So that's ongoing work, ongoing research, things like that. So every release that Q-Chem has We have contributions from, for example, the Het Gordon group, and some folks who have done the neo-DFT stuff from the Ham-Schiffer group, that and there's a lot of different groups making active contributions to the code, which means that in addition to being a very stable package, because we have our core office group sort of maintaining the integrity of the software and doing a bunch of checks and regressions and things like that before every release, we also have this active community that is making sure that new changes are incorporated into the code and active research is being done within sort of Q-Chem as a whole. So I think that's one of the primary advantages that we have over a lot of other softwares. Okay, someone has asked, in terms of calculation accuracy, whether Gaussian or Q-Chem is best. Gaussian doesn't let you publish any. We actually can't use Gaussian. We are banned from using Gaussian because anyway, there's history behind that. But anyway, I do think we should maybe go ahead and switch over to the tutorial session, because that's going to take about 30 minutes. But if you have any additional questions, please feel free to email me, I guess, or ask me. I don't know. We have a Q&A session at the very end of this talks as well. So yeah, we can go ahead and go into the breakout rooms now, I think.
Absolutely. Thank you so much, Shannon. That was really, really nice. I think it's always just super nice when you get to watch someone that knows what they're doing use the graphical interface for the first time. So thank you so much for that.
Thank you.
All right.